NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the previous Electrical Engineering GATE 2022 exam questions solutions from circuit theory. This video content is not only for electrical engineering. This is for EEE ECE instrumentation because the circuit theory content is common for EEE ECE and instrumentation. Okay. First, in the part 1 videos, we will discuss the EEE department questions. In the part 2 videos, we will discuss the ECE department questions 2022 examinations. Part 3 videos, we will discuss the instrumentation questions. Okay, one by one. So now we will discuss the EEE department questions, GATE 2022 exam questions. First, I will list the questions. What all are the questions asked in GATE 2022 electrical engineering examinations? Then we will solve one by one. The first question is asked from the resonance circuit concepts. Then second questions. The second questions also asked from resonance concepts. If you ask, we go to find the quality factor. Third questions from transient response concepts. Then fourth questions from star to delta conversions. Then fifth questions from supermesh and node concepts. Totally 5 questions are asked in the GATE 2022 electrical engineering questions. All the questions are 2 mark questions. So totally 10 marks. Now we will discuss the 5 questions one by one. So first we solve the first questions. The objective of the first question is, here inductor and capacitors are connected in series. The quality factor of inductor and quality factor of capacitor is given 60 and 240. We go to find the overall quality factor of the circuit. Already we discussed the resonance concept. Just refer the resonance concepts video. If the quality factor of inductor and quality factor of capacitors are connected in series, then the combined quality factor of the circuit will be Q is equal Q1 Q2 by Q1 plus Q2. It's a formula. Okay. So we know that quality factor of inductor and quality factor of capacitor Q1 Q2. Just substitute these values in this equation, we will get the quality factor of the circuit. So substitute, we will get Q is equal to 48. So the quality factor of the circuit is 48. Okay. If 2 quality factor elements are contained in series, the formula will be Q is equal Q1 Q2 by Q1 plus Q2. Okay, just remember the formula. Next, second questions. The objective of the question is, we have to find the quality factor of the network. Here resonance frequency is given 150 kHz and bandwidth is given 600 Hz. Okay. Already we discussed the resonance concepts video for series resonance and parallel resonance. We know that formula. We know that relations between quality factor, resonance frequency, bandwidth for series resonance circuit and parallel resonance circuits. Here the quality factor means the quality of inductor coil. Here L and R are connected in series. So we have to use the relations between the quality factor, resonance frequency and bandwidth for series RL circuits. We know that Q is equal to frequency by bandwidth. This is the formula. So substitute these values. What is the value of resonance frequency? FR is equal to 150 kHz. So 150 into 10 power 3. Bandwidth is 600 Hz. So 600. Simply this equation we will get 250. This is the quality factor for the network. Okay. Now we will solve the third questions. The question is asked from transient response, capacitor behavior concepts. Already we discussed the transient behavior of capacitor and transient behavior of inductor. Just refer that concept video. If you refer that video, definitely you can answer these questions. Objective of the question is, if the switch S is closed at T is equal to 0, what is the value of voltage across the 6 ohm resistor at steady state? Steady state means after long time of switch closed. That means T is equal to infinite time. So we have to find voltage across the resistor, 6 ohm resistor at T is equal to infinite bit after long time of switch closed. That is steady state. Okay. So we know the analogy of capacitor. What is the analogy of capacitor? The capacitor charging is likewise the charging of mobile phone. consider initially the mobile phone charge is 0. That means voltage across the capacitor is 0. If the mobile is connected with the AC source, what will happen? The maximum current will flow, the mobile will charge, it will start to charge. Similarly, the capacitor also starts to charge. So maximum current will flow at the time of switch closed. So it will act as short circuit because maximum current flows. After a long time of switch closed, what will happen? After a long time of mobile phone is connected with AC source, the mobile phone fully charged to maximum value. After that, there is no current flow through the mobile phone, there is no charge. After that, the maximum charge. Similarly, for the capacitor, if the capacitor is longly connected with DC source, it attains a maximum charge, fully charged. Now, the current flow through the capacitor is 0. So, it will act as open. So, at t is equal to infinite time, the capacitor acts as open. Okay. Now, replace the capacitors by open circuits because we have to find the voltage across the 6 ohm resistor at t is equal to infinite second. So, replace the circuit. Here, the branch is eliminated because the capacitor acts as open. We have to assume current I1 and I2 because we have to find the voltage across the 6 ohm resistors. You may use any method to find the voltage across the 6 ohm resistor. Now here we are using the mesh analysis method. Okay. Just apply Kirchhoff's voltage law for the loop 1. This is loop 1. This is loop 2. We know that Kirchhoff's voltage law. If you don't know, just refer to Kirchhoff's voltage law video also. Okay. We have to mark the polarity of resistive component in the direction of current. So plus minus because we got to assume the polarity in the direction of current. Now apply Kirchhoff's voltage law. If current flows from positive to negative, this is a positive voltage. So 6I1. Here I1 flows from positive to negative and I2 flow from minus to plus. So I1 minus I2 is equal to 0. Simplify this equation, you will get like that. Let us take this equation as 1. Now apply Kirchhoff's voltage law for loop 2. So just mark the polarity of resistive component in the direction of current. So here plus minus, here plus minus. In the 3 resistors, I2 flow from plus to minus, but I1 flow from minus to plus. So 3 into I2 minus I1 plus 2I2 because the current flow from plus to minus, so positive polarity, so 2I2. Here in the battery, current flow from positive to negative, so positive voltage, so plus 10 is equal to 0. Now simplify this equation, you will get, let us take this equation as 2. Now solve the equation 1 and 2. We will get I1 is equal to minus 0.833 amps, I2 is equal to minus 2.5 amps. But we need the voltage across 6 ohm resistor. We know the current flow through the 6 ohm resistor. So from that we can find the voltage across the 6 ohm resistor. Voltage across the 6 ohm resistor is equal to V is equal to 6 into I1. We know the I1 value. Substitute these I1 values here. We will get V is equal to minus 5 volt. This is the voltage across 6 ohm resistor at the time of steady state voltage. After a long time switch closed. Okay. Next we will discuss the question number 4. The objective of the question, we go to find the ammeter reading, phase current. Here star network is given and delta network is given. Just refer this star to delta and delta to star conversions. If you refer that video, you can solve this question easiest manner. Okay. So first convert the delta into star or star and delta, anyone. Okay. Here we will convert delta into star. What is the formula for conversion of delta into star? ZA ZB divided by ZA plus ZB plus ZC. Here all the values are same values. ZA, ZB, ZC, all are Z1. If you refer the star to delta conversions video, you can remember this formula in an easiest manner. Okay, just refer. So what is the value of Z1? Z1 is equal to 18 plus J24. Substitute here. we will get Z1 dash is equal to 6 plus J8. All these values are 6 plus J8. Now the equivalent circuit will become like that. Star component parallel with the Z1 dash. Okay. Here Z1 dash and Z2 are parallel. So the resultant phase impedance, if two resistors are parallel, what is the value? R1 R2 by R1 plus R2. Here Z1 dash, what is the value of Z1 dash? Z1 dash is equal to 6 plus J8. What is the value of Z2? Z2 also is 6 plus J8. Both are same. If two equal resistors are in parallel, the resultant will be half. So the result will be half. 6 half 3, 8 half 4. So you will get 3 plus J4. Next, the phase impedance is known. If you know the phase voltage, then we can easily find phase current. But here line voltage is given. For star network, line current is equal to phase current. Line voltage VL is equal to root 3 into V phase. So we go to find the phase voltage. If you know the phase voltage and phase impedance, then only we can find the phase current. So find the phase voltage. Here line voltage is given. VL is equal to 100 into root 3. Substitute here, you will get phase voltage is equal to 100 volt. Now find the phase current. Phase current is equal to phase voltage by phase impedance. Here phase voltage value 100, phase impedance value 3 plus J4. So from that, simplify this equation. What is the value of magnitude for 3 plus J4? You will get root of 3 square plus 4 square. You will get 5. 100 by 5 is equal to 20 amps. So the ammeter reading is 20 amps. Okay. Next, we will solve the last fifth one questions. We may solve these questions by using supermesh concepts or node analysis concepts. You may choose any one method. So just refer both the concepts, supermesh concepts and node analysis concepts. The objective of the question is, we go to find the voltage across 8 kilo ohm resistors, that means V1. Here we will use the supermesh concepts. By supermesh concepts, if a loop have the current source, we cannot apply the KVL for the loop because there is a current source. In the loop 1, there is no current source, only it have voltage source. So we can apply the Kirchhoff's voltage law for the loop 1. But loop 2, it have a current source. So we cannot apply the Kirchhoff's voltage law for loop 2. So first apply Kirchhoff's voltage law for loop 1. We will get loop 1 current is I. So 2I1, this current flow from positive to negative, so positive voltage, so 0.5 V1. Here this current flow from minus to plus. So we will get minus 75 is equal to 0. Simplify this equation, we will get, let us take this equation as 1. Okay. Now we need two equations because two unknown parameters, I and V1s are unknown parameters, so we need two equations. If you know another one equations, we can find I value and V1 value. How to find? By the loop 2, by the dependent source. By the dependent source, we go to find another one equations. Here this current is I, the current flow through the 8 kilo ohm resistance, that we can write another one equations. V1 is equal to 8 and I1. Yes, by Ohm's law, V is equal to IR, the current flow towards the resistor is I. So we will get V1 is equal to 8I. So current flow from positive to negative, so positive voltage. So all equation 1 and 2. Just substitute equation 2 in 1, we will get, because 0.5 V1, V1 is equal to 8I. If we substitute, we will get 4I. So 4I plus 2I, 6I is equal to 75. So I is equal to 12.5 amps. Current I value is known. If we substitute these values in equation 2, we will get V1 value. So V1 is equal to 8 into 12.5 is equal to 100 volt. So the voltage across the 8 kilo ohm resistor is 100 volt. Okay. In the part 2 videos, we will discuss the GATE 2022 ECE exam questions from circuitry concepts. Okay, good. Thank you. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IES, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You will get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.